Hello and welcome to the 5th episode of AWS DeepComposer Train It Again Maestro. Today we'll learn how to understand your model's performance and utilize metrics to measure model quality during training. Training is typically a lengthy and expensive process. It is important to keep a close eye on how the model is performing during training so that you stop the training process, saving your time and resources when the model reaches a point that it produces music that is pleasing to listen to. One important metric used to monitor progress and performance is the loss value. We discussed the two loss functions in our previous episodes, discriminator loss and generator loss. Loss shows how far the distribution of generated music is from the original dataset. As loss starts to reach zero, it means the generated music is close to the original source music. This process is called convergence and occurs when the adversarial nature between the two models starts to stabilize. Let's look at the metrics for the pre-trained symphony model. You get to those metrics by clicking on Models here on the left-hand side and then selecting the pre-trained model. Let's click on Symphony. This brings you to the main page for Symphony. Notice here up at the top there's some high-level information. It uses MuseGAN, and notice the number of epochs, 750. Down here on the bottom portion of the screen you'll see this graph, and it shows the discriminator loss here on this blue line and the generator loss here on this purple line. Both loss values are superimposed on the same graph, which can make it difficult to read. The scales are different. Notice down here on the x-axis we have the number of epochs. Here on the left-hand side, or the y-axis, we have the generator loss, and on the right-hand side we have the discriminator loss. And to make it easier to read, you can hide and show the different loss values. Let's look at the generator loss. So let's hide the discriminator loss first. The generator loss starts out here around 30, and notice it plateaus right here. Now that blue circle here is the 300th epoch. Here it plateaus probably right around the 350th epoch, and then it essentially stops improving. The discriminator loss, let's hide the generator and show the discriminator. The discriminator's loss, the behavior really starts to plateau right around here. I would say that's the 50th epoch. And then again, don't get confused. This circle here is the 100th epoch. And the plateau starts right over here, right around the 50th epoch. And we can verify that by listening to samples. So let's hear what music was produced at the 100th epoch. And you can do that over here by just clicking on this sample output button. So that was the 100th epoch. Let's listen at 400. So click on 400 and then play sample output. And now let's click on 700 and play it. You'll notice that the later epochs really start to sound like music. So that shows you that the model is getting better and better and better after each epoch. Now let's click on generated samples. There are several quantitative metrics that measure quality during training. And these metrics essentially take high-level measurements from the original source data. That's what they call the ground truth samples. The original source data, and then measurements from the generated music and determine how well the measurements align with each other. So the output samples, that's considered the generated music. Let's look at each of these metrics. The first one is pitches used. Notice here again, epochs shown here on the x-axis and pitches used shown on the y-axis. This metric shows the average number of notes in each bar. And a bar or measure is just really one small segment of music that holds a certain number of beats. This plot graph shows values for each instrument. For example, the contrabass is shown here in the red circle. The ocarina is shown here in the yellow triangle, and the French horn is shown here in the green inverted triangle. These straight lines here, so the green line, the purple line, the yellow line, and the red line, these lines represent the target. And convergence is reached when the generated samples are close to the target. For example, let's look at the contrabass. And the contrabass, it's this red pinkish circle. Notice at first that the contrabass is kind of all over the place. At epoch 30, it's down here. At epoch 60, it's up here. Epoch 110, it's back down here. But notice it starts to converge where it meets the red line right here, right around the 330th epoch, and then it continues to hold steady. So that's how you would read this graph. Next, we have pitch classes used. This metric shows the average number of notes in each bar after projecting to each pitch class profile. Now, a pitch class profile, that's related to octaves, and that's about as far as my musical knowledge goes. Again, the generated samples are represented by the shapes, and the target, that's represented by the line. And when the shapes start to meet the line, that shows convergence. Empty bar rate. This metric shows the ratio of empty bars to the total number of bars. Notice at first the contrabass, again, this is the red circle, it's all over the place, but it starts to converge right here around this 350 through 380 range, and then it really starts to hold steady for the rest of the iterations. Next, we have polyphonic rate. This metric represents the ratio of the number of time steps where the pitches are larger than the threshold number allowed. For example, look at this ocarina. So that's the yellow triangle. And this one converges very early on, almost from the beginning. So right around, let's say, the 40th epoch. Then it kind of goes off skew on the 60th epoch, but then it resets, and then it starts to hold steady. And there again, that's the yellow triangle matching the yellow line. In scale ratio, this metric represents the average number of notes in a bar to the total number of notes. And when we look at this graph, the French horn, that is the inverted green triangle, that one seems very stable when we compare it to the other instruments. For example, this contrabass, which just always seems to be all over the place at first and then starts to converge. There is one other metric that's not shown here on the symphony pre-trained model. It's called drum and pattern, and we can actually find that in the jazz model. So click back on models to go to the main page, and then click on jazz and click on generated samples. And then now notice there's this new one here called drum and pattern. This metric tracks the number of notes in the drum track. And like I said, this metric is not a part of every model, but drums are used in jazz. And if you just look at this graph, there's just one. To ensure the best model performance, keep a close eye on the model during training to see when convergence is met. If training continues, the discriminator feedback can become less and less meaningful over time, which means the generator will receive bad feedback from the discriminator. then its quality may diminish because the feedback is not as accurate. So it's a very tricky process. Well, that's it for this episode. We learned how to monitor your model during training using the loss function and how to understand your model's performance using quantitative metrics. Join me in the next episode where we'll put together everything we've learned and show the full capabilities of DeepComposer in a head-to-head music battle. See you soon!